Ha?
Okey, ni cikgu dah live ni saya sini.
Okey, tak apa, dah live lah. Tak apalah, kita start awal pun. Sebab saya pun dah ready, insyaAllah.
Okey, cikgu good luck.
Okey, thank you.
Alright.
Okey, apa-apa,
Okay.
WhatsApp kat saya. Cuma saya nak tengok dekat sini macam mana besarkan macam ni. Okey, kalau dah boleh start, macam mana saya nak dapat signal? Akilah WhatsApp saya, dah boleh start.
Okay. Saya WhatsApp kau dah tu. Okay.
Okey, thank
Alright.
you. Sebab dia bukan pukul 11 lagi kan?
Belum, tapi dah start dah cikgu. So, cikgu boleh lah macam cakap apa ke. Saya rasa sebab dah start dah.
Kejap, saya nak tengok chatting kat mana. Kejap, tengok dekat. Okey, tak apa. Assalamualaikum, hai. Okay. Assalamualaikum semua dan selamat pagi. Okay, so today I will like to talk about periodic table of elements. And basically this is the chapter form 4. Chapter 4 in form 4. And according to the DSKP or Document Standard Curriculum Pentaksiran, okay, our focus for today is this one. Okay, investigate through experiment the chemical properties of group Y elements with water, oxygen gas and chlorine. Of course, because we are at home, we cannot carry out experiment as in our lab at school. So we're going to show you some simulations. And then we're going to generalize the change in reactivity of elements when going down group 1. Okay, so this is our focus on today. First of all, you need to know what is group 1 element. Okay, group 1 element is on the most left side in the periodic table. Okay. And this is how sodium looks like. And this is lithium. This is potassium, rubidium, and cesium. And as going down the group, okay, the electron arrangement is like this. Lithium, hang on, it's to it's to 1, okay, and then sodium 281 and potassium 2881. So this is the electron arrangement of the atom. Actually, hydrogen is not included as alkali metal because hydrogen has different properties than the other metal like lithium, sodium, and potassium. Okay, regarding the reactivity of group 1 elements, atom of group 1 achieve a stable duplex or octet electron arrangement by releasing one valence electron to form positively charged, positive 1 charged ions. And for example, sodium atom, you can see that the electron arrangement is 281. So when you got 1 here, means that in order to achieve stable octet, sodium atom need to release 1 valence electron to achieve stable octet electron arrangement. And then it will become sodium ion. So when sodium ion, the electron arrangement is 2,8, means that it's stable. So in reactivity of group 1s, we can say that the reactivity is like based on the ability of the atom to release one valence electron. So the easier for the atom to release the valence electron, the element will become more reactive. Okay, so as going down the group, you can see that this is lithium, this is sodium, and this is potassium. Okay. And now it's going down group 1. The number of shell increase or the atomic size increase. We can see that this has 2 number of shell. Lithium just got 2 number of shell. Sodium 3 and potassium got 4. Okay. And then the valence electron in the outermost shell get further away from nucleus. Okay. As going down the group, we can see that the outermost shell or the outermost shell, this one, the outermost shell, get further away from the nucleus, and the nucleus is here in the middle. So this is the nucleus, this is the nucleus. And strength of attraction from the proton in the nucleus to the valence electrons get weaker. Proton is positively charged and located in the nucleus, and electron is the negatively charged and located at the valence electron is located at the outermost shell, and they have the strength of attraction. So when the valence electron is further away from nucleus, the strength of attraction will get weaker. Okay, sebab nucleus valence electron lebih jauh daripada nucleus, jadi dia punya apa kita kata the strength of attraction tu akan jadi lebih lemah. And then the electron is loosely held and it's easier for the electron to be released. Okay, so the easier for the electron to be released, therefore the reactivity increased. Or we can say that the reactivity of potassium is higher than sodium and lithium. Okay. Okay, Okay. So, there are 3 experiments to investigate the chemical properties of a group 1 element. First, the reaction with water. Second, the reaction with oxygen. And the third one, the reaction with chlorine. So now we're gonna look at the simulation, okay? We're gonna watch the simulations that help you to understand how the reactions of the alkali metal occurs with water, oxygen, and chlorine. And there are 3 metals involved only: lithium, sodium, and potassium. Rubidium and the rest at the bottom is very reactive, highly reactive, and is dangerous to carry out in laboratory. Okay, and then before that, wait, we need to go to the simulation now. Okay, alkali metal is very reactive with and can react with air and the moisture. So we have to keep the alkali metal in paraffin oil. So this is the alkali metal or elements in group 1. Okay, this is the sum of element and electron arrangements. Right, and this is sodium. Okay, we can see that the attraction forces between nucleus and electron valence. And this is sodium. Okay, the attraction forces between nucleus and valence electrons get weaker as the nucleus is valence electron is further away from nucleus. And this is potassium. Okay, we can see that the valence electron is further away from nucleus, and the attraction forces between nucleus and valence electrons is more weaker compared to sodium and lithium. Okay. Okay. During the experiment, what we want to observe is how quickly the metal move on the water surface, and what is the color of the flame produced, and how vigorous the reactions. Okay, and another one is the change in the litmus paper. That's why we put the litmus paper there. Okay, I repeat. You can see that lithium moves slowly on the water surface, produce red flame. And the moment you put the blue litmus paper, red litmus paper turns to blue, means that the solution produced is alkaline. And this is the chemical equations when lithium is added into water. Lithium hydroxide is produced together with hydrogen gas, and your solution now, okay, is alkaline because it consists of lithium hydroxide. So what we can say that from the observation here, lithium is the least reactive metals, and it reacts with water to produce alkaline solution, which is lithium hydroxide. Now we move to sodium. You can see that sodium move a bit faster. And when sodium reacts with water, it produces sodium hydroxide and hydrogen gas. Okay, alright. Sodium move quickly and produce yellow flame. And the solution form turns red litmus paper to blue. Okay, so sodium react with water to produce alkaline solution, which is sodium hydroxide. Okay, this is potassium. And the reaction is very, very vigorous. Okay, and we look at again. Okay. Right, so potassium is very reactive, more reactive compared to lithium and sodium. And it reacts with water to produce alkaline solution, which is potassium hydroxide. Now we look at three reactions together that occur on the same. You can compare lithium, sodium, potassium. Okay. Okay, yeah. I will repeat several times because I saw the comment is some of you, the video from your view is lag, eh? Okay. And we look at again. Okay. Okay. Now we look at the summary. We can compare here that lithium moves slowly and sodium moves quickly and potassium moves very quickly. Okay. And lithium react with water to produce lithium hydroxide. Sodium react with water to produce sodium hydroxide. And potassium is most reactive metal, so it produces potassium hydroxide here. Okay, hello Mr. T. I don't know why my internet is okay. I don't know why. Okay, now we move to the reaction of group 1 metal with oxygen. So what we want to focus here is how brightly the metal burns, color of flame produced, and the color of the product form. Okay, see, this is for oxygen. React with lithium. And now the chemical equation is lithium react with oxygen to produce lithium oxide. And the observation is lithium burns slowly with red flame and produce white solid. So the white solid here is lithium oxide. Okay. So, alright. So the lithium oxide here is the white flame. And then now we move to sodium. Okay, sodium react with oxygen to form sodium oxide. And then sodium burn brightly with yellow flame and produce white solid, okay, which is sodium oxide. And then sodium react with reactive metal. Sodium is a reactive metal towards oxygen and produce sodium oxide. So we produce sodium oxide. The product of the reaction is sodium oxide. And this is the reaction with oxygen. Potassium react with oxygen. Okay. And we produce potassium oxide. Okay. And then it will produce potassium oxide. So now we can compare those three reactions for the reaction metal with oxygen. Okay. You can go to page maryact.com and download the simulation here in case you found out this video is lag. Okay, you can install the simulation from the website maryact.com.my. So here are the summary. Okay, lithium burns slowly with red flame and produce white solid. So this is the white solid, which is lithium oxide. Okay. And then when the white solid dissolves in water, it forms colorless solution, which is lithium hydroxide. Okay, so means that when we add water into the lithium oxide, it will produce lithium hydroxide. Okay. Alright, and then potassium burn very vigorously or very brightly with purple flame to produce potassium oxide. And then this is a white solid. Potassium oxide will dissolve with water. When we dissolve with water, it produces potassium hydroxide. Okay. Now the reaction of group 1 metal with chlorine. Okay. Alright. When according to the reaction with chlorine, what we want to observe is how brightly the metal burns, color of the flame, and color of the product. Okay. And this is the chemical equation. When lithium reacts with chlorine, it produces lithium chloride. Lithium burns slowly and produce red flame with a burning with a red flame to produce white solids. Okay. And then lithium is the least reactive metal towards chlorine. Lithium reacts with chlorine to produce lithium chloride. Okay. So before in this reaction, we just cut the metal, lithium, sodium, potassium, and we add into gas char. So now, okay, sodium burns brightly and then produce white solids. And then sodium is reactive metal towards chlorine. Sodium reacts with chlorine to produce sodium chloride. When sodium reacts with oxygen, it produces sodium oxide. Now, sodium reacts with chlorine, produce sodium chloride. Okay, the third one. The reaction of group 1 metal, which is potassium with chlorine. Okay, it burns more brightly. And potassium reacts with chlorine to produce potassium chloride. Okay. Potassium burns very brightly and burns with purple flame to produce white solids. And potassium is very reactive towards chlorine. And we can compare now 3 reactions between lithium, sodium, and potassium with chlorine. Okay. Okay, so we look at the summary for those reactions. Lithium burns slowly, sodium burns brightly, and potassium burns very brightly because potassium is most reactive compared to sodium and lithium. Okay, and lithium is the less reactive metal. React with chlorine to produce lithium chloride. This is the lithium chloride and it's a white solid. Okay. Same goes to sodium. Burn with chlorine to produce sodium chloride. You just change lithium, and now when we sodium chloride, and also white solid. And then potassium, when react with chlorine, produce potassium chloride and also white solid. Okay. So now we recap again the reactions. Okay. Okay, now we recap again the reaction between group 1 metal with water. Okay. Actually, we just cut the metal very tiny. And remember, we have to clean the metal with uh, filter paper, because the alkali metal we kept in paraffin oil to avoid the reaction with air. So now the reaction with oxygen, all the reaction will produce metal oxide. Lithium react with oxygen to produce lithium oxide. Sodium react with oxygen, produce sodium oxide. And same goes to potassium, we produce potassium oxide. All the metal oxide here are white solid. And this is the reaction with chlorine. Okay. Lithium will react with chlorine, produce lithium chloride. Sodium will produce sodium chloride when react with chlorine. And potassium react with chlorine to produce potassium chloride. And those chloride are white solid. Okay. Okay. Now, we're going to try out some question. Okay. Again, the simulation that I show you just now, you can get from this website. Okay, you can go to the website now. Okay, let's try out some question. We got about half an hour left. Okay, in order to see whether you understand the content or topic for today. Okay. First, we start with question. Compare and explain the reactivity of elements X and Y. Okay. Actually, this question will contribute about 4 to 5 marks. And student mistake is, from my experience as a teacher, when we give this student when we give this question to the student during class as exercise, student mistakenly answer the question because the question asks you to compare. Okay, the question asks you to compare, but the way student answer is like general term. Okay, for example, like this one, as going to group down, the number of shell increase and blah blah blah. Okay, that's a general explanation, but now we need to compare. So this is incorrect and explanation. So the best way to explain the question, the best way to answer and explain the reactivity of elements, of two elements like this are, first, we say that element Y is more reactive than element X. Okay, why element Y is more reactive than element X? Look at electron arrangement here, 2, 8, 1. Alright. Sorry, proton number is 19, 2, 8, 8, 1. Okay. And of course, both element X and Y are in group 1. And X is located above than Y. So in terms of reactivity, Y is more reactive. Okay. Next, we mentioned about electron arrangement. Okay. Electron arrangement of atom X is 281 and atom Y is 2881. When you write electron arrangement, never write this form. You know, sometimes students love to write in ratio form, which is wrong. Okay, I repeat, don't write electron arrangement in ratio form. And then the number of shell occupied with electron of atom Y is more than atom X. Or we can say that the size of atom Y is larger than atom X. And then the distance between nucleus and valence electron is further. Okay, after we talk about size or number of shell, we talk about distance, but we still compare. Okay, we compare distance between nucleus and valence electron in atom Y and atom X. And then force of attraction between nucleus and valence electron for atom Y is weaker. When the force of attraction is weaker, means that the electron valence is easier to be released. Okay, easier for atom Y to release valence electron compared to atom X. That's why atom Y is more reactive than element X. Okay, alright. Okay, Okay, second question, I pick up from past year previous SPM question for 2010, which is in paper 1. Which statement explain why reactivity of group 1 elements increase when going down the group? So this is the question. Alright. Now, what? I give you like a bit time. You read the question and try to answer. And you may put on the comment. Okay. Alright. Give the comment. For example, like question 2. What's the answer? Okay. Okay, student. You may put on the comments. Okay. Okay. So which statement explain why reactivity group 1 element increase when going down group? Okay. The answer is, alright, the valence electron gets further away from nucleus. Okay. The answer is C. Okay. Because the question asks which statement explain why reactivity element increase when going down the group. Okay. If you said that A and D totally doesn't make sense because it's nothing to do with the explanation of reactivity. So B and C might confusing you. But look at the statement here for B. The attractive forces between electron and nucleus become stronger. Okay. As going down the group 1, the attraction forces is not stronger, it's weaker. So that's why the best answer is C. Okay, this one is wrong. It's not stronger, it's actually weaker as going down the group. And the answer is C. So who answers C is correct and well done. Okay. Now the next question. Okay. Name the solution form when lithium reacts with water. Okay. You may answer at the comment. You put like question 3, dash and the answer. Okay. Question 3. Name the solution form when lithium react with water. And the answer is lithium hydroxide. Okay. When the question asks you about name, make sure you give name. Okay. Reject if you answer like this. Because LiOH is the formula, not the name. So when name, you have to give the full name for the compound of the solution. And the next question is, sodium react with oxygen to form a white solid. Name the white solid. Okay, the answer for this one is sodium oxide. Okay, look at question 4. Write chemical formula of the compound formed when potassium react with chlorine. Okay, write chemical formula of the compound formed when potassium react with chlorine. Okay, Most of students can answer it correctly. Very well done. Okay, big clap who those answer the question correctly. Okay. For question number 4, be very careful with the compound name. I mean like the compound, the question asks you, potassium react with chlorine. So what is the formula for potassium? K or Na? Yes, the answer is KCl. Okay, the best way, the correct way to write the formula is K is the capital letter, C is capital letter, and L is the huruf kecil one. Okay, if you write like this one is wrong. And the question asks you chemical formula, not the chemical equation. I saw some answer write about the chemical equation, which is incorrect. Read the question carefully, is chemical formula, not the chemical equation. If chemical equation, yes, K plus Cl and you will get KCl. And who answer potassium chloride with full name is wrong because the question asks you write chemical formula. Okay, I repeat. Who answer potassium chloride, Potassium chloride is wrong because the question wants chemical formula. Okay, we try a bit challenging question now. Okay, look at question 5. Metal X, Y, and Z are alkali metals. Metal X, Y, and Z are put into spirit basin containing water, and table below shows the observation of the experiment. So from the table, we can see that metal X moves quickly on water surface, metal Y move very quickly, and metal Z move very slowly. And the question asks you, Arrange the size of metal X, Y, and Z in increasing order. The question didn't ask you about arrange reactivity, but arrange the size. Okay. You may try question number 5, which is the last question for today, because our session almost going to the end. Okay. And then look at the observation. We know that X, Y, and Z. And in group 1, because it say alkali metals, of course, hence is in group 1. So in group 1. And we know that as going down the group, reactivity increase. Okay. And then look at which one is the most reactive, which is Y. So we put Y at the bottom. And second one is X. And the first one is Z. And the question said arrange the size of metal X, Y, and Z in increasing order. So as going down the group, the size increase. So the answer is Z, X, and Y. Okay, I saw some student answer it correctly. And this then the question like this, you have to be very careful. You have to analyze properly. Don't read the question too rush. Otherwise, you will miss the important point. I don't reckon student answer like Z dash X dash Y. You better put Z, comma X, comma Y. Yes, increasing order means from small to big. Thank you very much, Ryan Tang. Okay, so we just got about 3 minutes left. Is there any question? Okay, again, if you want to watch the simulation again, you can go to Marriott website and download there. Okay, guys, thank you very much for today. Thank you for your cooperations. Okay, hope you enjoy the lessons and you learn something from it. Oh, I'm sorry, Ryan. I'm sorry for pronounce your surname wrongly. I'm sorry. And take care, everyone. Stay safe. Even though you are in PKP and I know you miss your school so much, but keep the momentum of studying on track. The link of the experiment you can go to marriott.edu.my. DIDIK Classroom also put the link of the website. You need to scroll down the previous post in DIDIK Classroom. Okay, you're welcome, guys. Okay, take care, everyone. Love all of you. Even though we never met each other. Okay, happy fasting for Muslim students.